There's an experiment that we do with water, looking at the microbiology of water, trying to test to see essentially what's in the water. This can often be done to determine, is water safe to drink? Is it safe for recreational activities? Or maybe it can be used, say, for watering golf courses, but not for human consumption. One thing that you're going to have to do is determine how many bacteria are in the water sample. So per milliliter, what's the concentration? Usually you're looking at the bacteria. There's numerous ways of doing this. There's a filtration method. Another method is called the MPN, the most probable number. And that's what we have set up here. So we have a water sample that we obtained. Now I have already inoculated these tubes. They have phenol red in them as an indicator, has lactose, and they're at different strengths. So this is a double strength phenol red with lactose, and in these I put 10 milliliters of water. In this middle section here, we have, once again, the phenol red with the lactose, and I put 1 milliliter of water, and then in the last row over here, I only put 0.1 milliliter of water. So you have 3 different dilutions. We're going to incubate these for 24 hours at 37 degrees C. Excuse me. You can see how it looks. Like I say, I just inoculated them. They have the Durham tube in it. We will see if gas is produced. Has the phenol red pH indicator in it, so we can see if acid is produced. And we can compare at these 3 different dilutions. This will not give us an exact number, but it's an estimate of how many bacteria will be in the original sample of water. And so when we look at the results, then at that time I will show you how you also need to look at an MPN table, a most probable number table, and you get the estimate of number of bacteria per milliliter. That's what we're looking at. How many bacteria are in the water? In this process, we had 5 tubes at different concentrations that we added our water sample to. This was a double strength phenol red lactose. All these are lactose. In this first one, we added 10 mils of the sample, then 1 mil, and then 0.1 mil. You have the phenol red pH indicator. If acid is produced, it would turn yellow. That is what you would be looking for as a positive result. You also have the inverted Durham tubes to collect gas if gas was also produced. On these particular samples, you will notice that none of them have turned yellow. It is possible if we left them a little bit longer, they might, but on the other hand, it's good that this obviously is a fairly clean water sample in terms of enterics that may be present in it. If some of these had turned yellow, what you would do, the way you would normally analyze it, is you would count the number of positives, the number of yellow tubes, so the acid production, in each one of these sets. And so you have to record the numbers separately. You don't add them all together. So you're going to end up with 3 numbers. So just as an example, let's say in the first set you had all 5 tubes were positive. You'd write it as a 5. With the 1 mil sample added, if 3 of the tubes were positive, you write a 3. And then in the last set with 0.1 mil added, if only 1 tube was positive, then you'd record the number 1. So you record it as 531. Then you would go to, there's a standard book or chart, excuse me, where you would go to look up that number that you recorded. So in our case, we look at, find 531. And then this next column is the most probable number index per 100 mils. So what does this number right here tell you? 110. That tells you that it's an estimate. That's all it is an estimate that there would be 110 organisms per 100 mils of water sample. Your confidence level here, think of it as the low would be 34 and the high would be 250, but this is the number that you're looking here. It says 110 per 100 mils. So it's an estimate of giving you the number of bacteria per milliliter in that water sample.